Now let's try to solve example number 3, which is finding an unknown side length. So the problem is find the value of x for the given right triangle here. So in solving this kind of problem, we will be following some simple steps. So the first step will be to identify the givens. So the first given is theta. So our theta is here. Remember, theta is an angle. So that's 30 degrees. Second is h, which is the hypotenuse. The hypotenuse is 8 units. In identifying the hypotenuse, we will be using our right angle as our reference. So the side opposite to that right angle will be your hypotenuse. And lastly will be your A, which stands for your um, adjacent side, which is your X, which is the problem. Now, how do we identify our opposite and our adjacent? We will use our theta, the given theta, as our reference angle. So since this is our reference angle, the side beside it will be your adjacent, and the side in front of it will be your opposite side. That's how to use your theta as your reference angle. Second step will be to choose which trigonometric ratio to use. Now, from the last problem, I introduced to you 6 trigonometric ratios, but to make our solution simpler, we will be dealing with the three basic trigonometric ratios, which are sine, cosine, and your tangent. Now, I'll be introducing to you three acronyms. The first is SO. Sorry. So it's SO. Let me erase that. So the first one is SO. Second is Ka. And the third one is TOA. So SO stands for sine is equivalent to the ratio of your opposite over your hypotenuse here. Second is Ka. Ka stands for your cosine tangent is equivalent to the ratio of your adjacent side over your hypotenuse. And lastly, TOA, which is tangent theta, is equivalent to the ratio of your opposite side of and your adjacent side. So that's SO, Ka, TOA. I hope this will be easier for you to recall the three basic trigonometric ratios. Now, how do we pick now? How do we choose which trigonometric ratio are we going to use to solve this problem? Now, to do that, we will be going back to the given. So look at the given. So the givens are theta. So all trigonometric ratio has theta. We move on to the hypotenuse. So we have here hypotenuse. So going back here, we only have the sine and the cosine, okay, having that hypotenuse. Now we have here adjacent angle. Okay, that's the problem. So for sine, we don't have adjacent, but for cosine, we have adjacent. So meaning we will be using cosine theta here is equivalent to adjacent over hypotenuse to solve that. That will be your step 3, which is to plug in your given using the trigonometric ratio. Okay. Trigonometric ratio cosine theta is equivalent to adjacent over hypotenuse. Now you plug in your given. Our theta is 30 degrees. Adjacent is x. Hypotenuse is 8. Now let's do our simple math. Let's solve for the missing variable, which is x. So the first step or the next step will be to express our left side of the equation as ratio, okay, to have a proportion over here. Since we have here a ratio to the right, we must also have here a ratio to the left. Why? Because I want to apply here cross product or cross multiplication. So to do that, let's multiply now cosine 30 degrees and 8 and multiply your x and 1. So simplify that. 1 times x will give us x. Cosine 30 degrees times 8 now, okay, To find the value of that, you should now use your graphing calculator or your um, scientific calculator, but make it certain, okay? Make it certain that you are in the degree mode, because you have two modes there. It's either degree or radian. Degree is the symbol you'll see there in your calculator. If you're in degree, is DEG, and if you are in the radian mode, you have the RAD. Okay, make it certain you are in in the degree mode. Why? Because in the given we have here degrees, so you should be in your degree mode. So if you plug that in your calculator, you'll have x now is equivalent to 4 square root of 3, or that is equivalent to around 6.93. So that is now the length of your adjacent angle here, which is your x.